Hello, my name is Miss Jones. I teach elementary school math, and welcome to my channel, Miss Math Jones. Today we're going to be working on our third grade Eureka Module 5, Lesson 23 homework. Let's get started. The objective for our homework is to generate simple equivalent fractions by using visual fraction models and the number line. Number 1 says, write the shaded fraction of each figure on the blank. Then draw a line to match the equivalent fractions. So if you take a look at my screen, I have one side that shows scratch paper, right? And on that side, I'm going to be showing you how to figure out or find equivalent fractions. But first, let's go ahead and write the shaded fraction of each figure in the blanks. So we're going to start with the very first one right here. We're starting right here. Okay, so what is the fraction for this figure? How many pieces are shaded? How many pieces do they have total? What should the fraction be for our first figure? If you said 1/2, you are absolutely correct because 1 out of 2 pieces are shaded, and you read that as 1/2. Let's look at our next figure. Our next figure has how many pieces shaded? How many pieces total? If you said that the fraction for this figure is 2/5, then you are absolutely correct. Let's move on to our third figure. How many pieces shaded does our third figure have? How many pieces total does it have? What's the fraction for our shaded figure number 3? 8/10. Very good. Very, very good. All right, let's take a look at our fourth figure. How many pieces are shaded? How many pieces total is that figure made of? Now remember, the shaded pieces, because that's what we're looking for, is our numerator. That's our top number. And the total number of pieces that is included in the figure is our denominator, or our bottom number. So what's the fraction of the shaded pieces? If you said 2/8, you are absolutely correct. All right, now let's take a look at this figure up here. How many pieces are shaded? And out of how many pieces total? All right, so the fraction for this figure is, if you said 4/5, you're absolutely correct. Now let's move on to this figure. Again, our numerator is the pieces that are shaded. How many pieces are shaded? And our denominator is the total number of pieces that the figure is made of. So how many total pieces is this figure made of? And now we put that together for the fraction. What's the fraction that represents the shaded area of this model? If you said 3/6, you are absolutely correct. Very good. All right, let's look at the next figure. Our numerator, or our top number, is the number of pieces that are shaded. How many pieces are shaded? That's right, 4. And how many total pieces is this figure made of? That's right, 10. So our fraction is 4/10. And our last figure on this page, how many pieces are shaded? If you said 1, that's right. And how many total pieces is this shape made of? 4. That's right. So that means that our fraction is going to be 1/4. Now, we have to draw a line to match the equivalent fractions. So I'm going to start with 1/2. I'm going to start up here with 1/2. Okay. I need to figure out what fraction or what other model is equivalent to 1/2. So to do that, I write 1/2 here. Now, we can count by ones in the numerator and twos in the denominator and come up with a whole list of fractions that are equal to 1/2. I'll show you what I mean. So our numerator is a 1. So we can count by ones and come up with a few fractions that are equal to 1/2. So after 1 is 2, then 3, then 4. And then I'm going to draw my fraction bar, right? And if I count by twos, what number would come after 2 if we're counting by twos? While I'm drawing my fraction bars, I want you to think about it. If we're counting by twos, what number would come after 2? If you said 4, you're absolutely correct. Now, we're still counting by twos because the fraction that we're trying to make equivalent fractions for is 1/2, okay? So if we're counting by twos, what number would come after 4? That's right, 6. All right. And one more, if we're counting by twos, what number would come after 6? That's right, 8. Now, we just created a list of fractions that are equivalent or equal to 1/2. Do you see one of those fractions on the other side for us to draw a line to? That's right. So 1/2 and 3/6 are equivalent. They're equal to each other. It would take 3/6 to equal 1/2. So we're going to draw a line from 1/2 to 3/6. All right, let's take a look at the very next fraction, which is 2/5. We're looking at 2/5, and we need to figure out what fraction or model is equivalent to 2/5 in the 2/5 model. So I'm going to write 2/5 here. And I'm going to do the same thing. I'm going to come up with a list of fractions that are equal to 2/5. And I'm going to do that by looking at my numerator, which is a 2. So that means when I come up with this list, every numerator has to be a multiple of 2. We have to count by twos. All right, so let's go ahead and start counting by twos. So my first numerator is a 2. So that means that my second one's going to be a 4. The next would be 6. And the last one is 8. Now I have all of my numerators that are equivalent, right, to that 2. I need to go ahead and come up with my denominators, or my bottom numbers, that are equivalent to that 5. So I'm going to be counting by 5s in the denominators, but I need to go ahead and draw my fraction bars before I get started. All right, I have my numerators, I have my fraction bars, and now I can count by 5s in the denominator. So 5 is already there. Next would be 10, then 15, and then 20. Now, do you see the fraction that's equivalent to 2/5 that's also on our paper? Good. 2/5 is equivalent or equal to 4/10. So we're going to draw a line from 2/5 to 4/10 because they're equal. All right, let's take a look at our next fraction, 8/10. Well, I can look at 8/10 and I know that if in the numerator I count by 8s, my next number is going to be 16 because 8 plus 8 is 16. And I know my denominators, if I count by 10s, then my next number is going to be 20 because 10 plus 10 is 20. And I don't have that fraction here. So maybe I need to figure it out another way. I'm going to pause right there with that fraction, and let's move on to the next one, 2/8. All right, let's see if I can figure out the equivalent fraction for 2/8. Well, at the top in my numerators, I'm going to count by twos. So that means that my next number is going to be 4. And I'm going to draw my little fraction bar. And if I count by eights, then I know my next number is going to be 16. Do I have 4/16 on this paper? No. So I'm going to have to do that a different way as well. So I'm going to use the fractions on the other side of the paper to figure it out. That's what I'm going to do. So I'm going to start up here at this model. This model doesn't have an equivalent fraction assigned to it yet, so let's figure it out with that one. So that fraction is 4/5. I'm a little squiggly line down my scratch paper here. And I'm going to write 4/5. Now, let's look at that numerator. It's a 4. So to figure out the equal fraction or equivalent fraction, I count by 4s, or I could double that 4. Well, if I count by 4s, what number would be next? That's right, 8. And it would be the same if I said 4 plus 4, because 4 plus 4 is 8. But that's the same as counting by 4s, because that's 2 4s. Now let's draw my fraction bar here. And at the bottom, we're counting by 5s. What would be the next 5 if I'm counting by 5s? That's right, 10. And it would be the same if I said 5 plus 5 is 10, because you can double a fraction, the numerator and the denominator, to get the equivalent fraction. So now I have 4/5 and 8/10. Do I see the matching fraction on my paper now? The fraction that's equivalent to 4/5? I do. It's 8/10, and it's on the other side. So now we draw a line from 4/5 to 8/10. There it is. And the only one that's left is 1/4 and 2/8. Well, they're obviously equivalent, but let's take a look at how. So we have 1/4 here. And remember, I said we can double our numerators. So by doubling, you just add it to itself, like 1 plus 1. Well, what's 1 plus 1? 2. And we draw our fraction bar. And what's 4 plus 4 in the denominator? What would 4 plus 4 be? That's right, 8. And it works the same way. If I'm counting by 1s in my numerator, the next number would be 2. If I'm counting by 4s in my denominator, the next number would be 8. So that means that 1/4 is equivalent to 2/8. So I draw a line from 1/4 to 2/8 when I do my matching, because 1, those are the last 2 left, and 2, they are actually equivalent. Now, if you need to pause your video to make sure that you have everything written down, go ahead and do so now. Let's take a look at number 3. Number 3 says, why does it take 3 copies of 1/6 to show the same amount as 1 copy of 1/2? Explain your answer in words and pictures. So since we're comparing, I love to use a rectangle that we split in half. So first, I want you to draw a rectangle on your paper. And we're going to be cutting it in half with a horizontal line, a line that goes straight across. So let's draw that also. Now, once you have your rectangle and your horizontal line that cuts it in half straight across the middle, I want to partition or divide the top half into halves. Well, that's easy because we only need one line. Now that that top half is divided into half or halves, we're going to shade one half and label the other one. So we're going to do this. Shade one half, and we're just going to label the other one 1/2. So now we've shaded 1/2. We've partitioned 1/2, we've shaded 1/2, we've labeled 1/2, okay? That's done. Now, the next step is to partition the bottom of this rectangle into sixths. So it's very important that you make your lines as close to where I make mine so that comparing the fractions 1/6 and 1/2 makes sense. Okay, so we're going to draw our first line right about here. Okay, our second line should be right about here. And our third line should be right there underneath that half line. It needs to be right there, directly underneath there. Now, we're going to do the same thing to the other half. So we need to put our lines in about the same place, okay? So we're going to put our first line here, okay? And then our second line right here. Now, if you count your sections, you should have 6 pieces. All right, so that means we've partitioned the bottom of our rectangle into sixths. So what we're going to do is we're going to label our 1/6 and we're going to shade the ones that are equivalent or equal to 1/2. Now, I want you to look at 1/2, right? So take a look at 1/2 and look down at your sixths that you partitioned. How many of your sixths, how many 1/6 would equal 1/2? How many 1/6 would take up the same space as 1/2? Now, if you said 3, you are absolutely correct. So what we're going to do is we're going to shade in those 3/6 that are directly below our 1/2 that we shaded in. So let's go ahead and do that now. We're going to write 1/6 here, shade it in. We're going to write 1/6 here and shade it in. And we're going to write 1/6 here and shade it in. Now, we're still going to label our other sixths, so let's go ahead and do that now. So now, both the top of our rectangle, which is in halves, and the bottom of our rectangle, which is in sixths, is partitioned correctly, and we've shaded in the equivalent or equal fractions of 1/2 and 3/6. Now, the directions tell us to explain our answer in words and pictures. So this model has explained our answer in pictures. Now we have to explain our answer in words. So in words, it takes 3/6 to make the same amount as 1/2. Because there is triple, which means 3 times the number of equal parts in sixths than halves. So it takes triple, which again means 3 times the number of copies. So it takes 3 copies of 1/6 to make 1 copy of 1/2. Now you may want to pause your video to make sure that everything on my screen is on your paper. Now let's take a look at number 4. Number 4 says, how many ninths does it take to make the same amount as 1/3? Explain your answer in words and pictures. So, as always, since we're comparing two fractions, I want a rectangle. Love rectangles for comparing fractions. And we're going to take that rectangle and we're going to split it in half horizontally. So at this point, you should have a nice size rectangle here, and it should be split in half horizontally. All right. Now, we're going to partition the top into thirds. So we need 2 lines. All right, so let's put one line about here and the other line here. And since we're comparing a third, at the top, we're going to shade in 1/3, and we're going to label the other 2/3. So let's go ahead and label and shade in 1/3, and then we're just going to label the other 2/3. Now, at this point, your paper should look like my screen. Now it says, how many ninths does it take to make the same amount as 1/3, which means the bottom needs to be partitioned into ninths. Since we're using a fraction strip, we need 8 lines to make ninths. So let's go ahead and make our 8 lines to create ninths. Now, be very careful about where you put your lines, because 2 of those lines at the bottom need to line up with those 2 lines at the top. And I'll show you what I mean. So let's start partitioning the bottom into ninths. So our first line should be about right there. And your second line should be here. Now this line has to line up with the one at the top. So let's draw it right there. Make sure those lines are lined up. Make sure they're the exact same. Okay, you just follow that line right on down. Now our next line should be about here. Your 5th line should be about here. And your 6th line should line up with the thirds at the top. The second line of the thirds, your 6th line should line up with that. So should be right there. Should line up, okay? Now we only have 2 more lines to go. And line number 7 should be here. And line number 8 should be about here. Now if you need to pause your video to make sure that your lines line up where they're supposed to, go ahead and do so now. Now, if you've made sure that so far your model looks like mine, then great, okay? Because your model should look like my model. Now, we need to take a look at our 1/3 that's shaded. How many ninths would it take to take up the same amount of space as that 1/3 that we have shaded? Look at that third and look directly below it. How many ninths would we have to shade in to take up that same amount of space? If you said 3/9, then you're absolutely correct. So what we're going to do is we're going to shade in those 3/9 that are directly below 1/3, and then we're going to label the rest of our ninths. So let's go ahead and shade in our 3/9 that are below 1/3. And then we're going to just label the rest of our ninths. Just going to write 1/9 in there. Label the rest. Very, very easy. Now, at this point, you need to make sure that your paper looks like my screen. And we've not quite finished answering the question because it says explain your answer in words and pictures. So we've explained it in pictures. We need to explain it in words. So here's our response in words as far as our explanation. It's not very long. It takes 3/9 to make 1/3. 1/3 equals 3/9. Now, if you need to pause your video to make sure that your response looks like my response, then go ahead and do so now. All right, and here we are at number 5, which is our very last question of our homework. And number 5 says, a pie was cut into 8 equal slices. If Reuben ate 3/4 of the pie, how many slices did he eat? Explain your answer using a number line and words. Now, anytime I see the word pie, I want to draw a circle, but the instructions tell us to use a number line. So that's what we're going to do. Now, we're comparing 2 fractions, which means we need 2 number lines, okay? So let's go ahead and create our first number line. So we need a line. And we need to create an endpoint at 0 and an endpoint at 1. So we have our two endpoints. And now we need to label our endpoints, 0 and 1. Now, our first number line is going to be in eighths because it says a pie was cut into 8 equal slices. So I know I need eighths. So let's go ahead and label our number line. And we're going to partition it into eighths. So first we're going to start by labeling 0 eighths. That's already done. And we're just going to put our lines there. So we need 1, 2, 3, 4, 5, 6, 7. And we have 8 lines, but remember that 8th line is on that whole number because it takes 8 eighths to equal 1 whole. And let's go ahead and label our eighths now. We're going to label our eighths now. Now, remember, make sure that your number line looks like mine so that when you are labeling your eighths, they're in the right position. Okay, so we start with 0 eighths, right above there. And then we start counting up because it is, after all, a number line. So we say 1 eighth goes here, 2 eighths, 3 eighths, 4 eighths, 5 eighths, 6 eighths, 7 eighths, 8 eighths. And 8 eighths is the same as 1. All right, now that we have partitioned our first number line into eighths, our second number line needs to be in fourths because it says, if Reuben ate 3/4 of the pie, how many slices did he eat? Okay, so let's go ahead and make another number line. And we need our endpoint of 0 here and our endpoint of 1 on the other end. And we need to partition it into fourths. So we need 3 lines. 1, 2, 3. And our fourth line is on the number 1 because 4/4 is 1 whole. Each line is a fourth. All right, now we need to go ahead and label our fourths. So let's start at 0, which above it, we're going to write 0/4. Then on the first line, it's 1/4. The second line is 2/4. The third line is 3/4. And the fourth line is 4/4 or 1 whole. Now, let's take a look at that question again. A pie was cut into 8 equal slices. If Reuben ate 3/4 of the pie, how many slices did he eat? Okay, well, I'm going to circle 3/4, and then I'm going to look to see what eighth is in the same position on the number line as 3/4, because that means that they're equal or equivalent because they're in the same place on the number line. So when I take a look, I see that 6 eighths is directly above 3/4. So that means that 3/4 is equal to 6 eighths. So he ate 6 out of the 8 pieces of pie. Now, it says to explain our answer using a number line and words. So we use the number lines. Now let's use words. So in words, 3/4 is equal to 6 eighths. I know this because they are in the same place on the number line. Also, if you use the count up method to find equivalent fractions, then 3/4 is equal to, so I've talked about this before. In our numerator, we start with the 3, which means we count by 3s. So if we're counting by 3s, our next 3 would be 6. In our denominator, there's a 4, which means at the bottom or in our denominator area, we're counting by 4s. So if we count by 4s, our next number would be 8. which means 3/4 is equal to 6/8. Also, if you were to double it, you'd get the same answer. 3 plus 3 is 6. 4 plus 4 is 8. So you could either use the count up rule or the double rule. Either way, you'd get the same answer. So Reuben ate 6 pieces of pie. Now, you might want to pause your video to make sure that everything on my screen is on your paper. Congratulations! Lesson 23 homework is complete. As always, I hope this video has helped you to complete your homework correctly and to understand Lesson 23 a little bit better. As always, make sure you check your work when completing math just to make sure that your math is mathing. And this is Miss Jones saying bye until next time.